pull them out from last year. You still got it all, right? So, with calculus, we see trig functions all the time. And remember when we dealt with them, we had degrees and radians that we could use. In calculus, everything has to be in radian form before we can do any of the calculus stuff to it. So if I ever gave you a problem with degrees, the very first thing we would do is change it into radians. Anytime I don't tell you, we're going to assume that it's in radians. So degrees are not something we are going to be using very often here. But on our unit circle, let's make sure we remember this stuff. So we did degrees, radians, ordered pairs. So my degrees, remember our hand trick, these were the common ones. So this would be 0 degrees. Then what do we go to? 30 degrees. Okay, if I jump down here, this is, and then we subtract our reference angle going up. So 180 minus 30, 180 minus 45, 180 minus 60. Okay, third quadrant, we add the reference angle. So 180 plus 30, 180 plus 45, 180 plus 60, 180 plus 90. Okay. Remember, 0 degrees, we also said you could call it 360. So for these, you did 360 minus the reference angle. So 360 minus 30, 360 minus 45, and 360 minus 60. Okay. And you have to have a degree symbol on all of those, because if we don't have any symbol, it's assumed to be radians, which is very different. All right, did we get the degrees? When we're talking about radians, what do most of those have in them? The pies. You start seeing pies. Yeah. So 0 degrees is like 0 radians, or 360 is the same as 2 pi. 30 is pi over 6. 45 is pi over 60. 90. Do you guys remember how we got those? We said 180 degrees is the same as pi. So if you were converting 60 degrees, for instance, you would take it times pi over 180. And 60 goes into 183 times, which is where the pi over 3 came from. So we could do that on all of them, multiply by pi over 180 and convert. But we know we have patterns. All of these, with the reference angle, the denominator doesn't change. So this will still be something pi over 6, because it was a 30 degrees, something pi over 4 because it was a 45, something pi over 3 because it was a 6. In the second quadrant, think about how we get those. We do 180 minus, or in this case it would be pi minus. So the top was, right, we did 1 less than the denominator. So if this denominator is 6, the numerator was 5. This would be a 3 pi over 4, 2 pi over 3. You guys remember that pattern? It's been a bit. So here we have the same setup. So pi, this was a 30 degrees, so pi over 6, pi over 4, pi over 3. And in these, we got it by doing 180 plus. So this is bigger than pi. So the top is 1 more than the bottom. So 7 pi over 6, 5 pi over 3, or 5 pi over 4, 4 pi over 3. This would be what? 3 pi over 2. Fourth quadrant, denominators are the same. Okay, the pattern here. Think about, in degrees, you do 360 minus. So in radians, we do 2 pi minus. So what was the pattern? Double minus 1. So 6 times 2 is 12, minus 1 is 11. 4 times 2 minus 1 is 7. 3 times 2 minus 1 is 5. And so that would be our final answer. All right. Degrees and radians. Ordered pairs. In those ordered pairs, do you remember what the x represented? is sine theta. All right. Useful to review the hand trick as we go, because ideally if you're in the middle of a calc problem that involves a trig function, you don't want to have to fill out an entire unit circle to answer your question, right? So remember our hand trick. Our fingers were 0, 30, 45, 60, and 90. All right, so for 0 degrees, if I fold in the 0, remember the pattern for both of these was a square root of something divided by 2. All right. Where did we look to get the sine? Sine was above, cosine was below, okay? So my order pair, I need cosine first. So cosine, how many fingers do I have below the one I folded down? 4. So square root of 4 divided by 2. So square root of 4 is 2, 2 divided by 2 is 1. Okay, how many fingers do I have above? 0. So square root of 0 divided by 2 is 0. Alright, doesn't that make sense if you're applying this on an XY graph? This is 0, 0. This is a circle of radius 1, so that would be 1, 0. So for 30, fold in your 30. Cosine is the bottom. We have 3 fingers below the one I folded down, so that's radical 3 over 2. Sine, I have 1 finger above, so the square root of 1, which is 1 over 2. 45, cosine, below, we have 2, so square root of 2 over 2. Above, we have 2, square root of 2 over 2. 60, below, I have 1, square root of 1 over 2 is 1/2. Above, we have 3, square root of 3 over 2. 90, remember my pinky doesn't fold, in case you forgot that fun fact about me. So, cosine,
Sorry, did you break it?
no, I just can't fold in my pinky. Can you?
Sort of.
Mine does not work. So cosine, how many fingers do I have below? Or sorry, cosine above was 4. Below we have 0. So my cosine is 0. My sine is 1. Alright, once we have those, the rest just kind of fall into place because we know the order pairs are the same for your reference angles, but we just have to watch in the second quadrant what's true. Yeah. If you're applying order pairs in the second quadrant, the x is negative, so that means all these cosines are negative. In the third quadrant, what's true? So you'll notice everything that has a 6 on the bottom, the order pairs are the same, just the only difference is the positives and negatives. So this would be 0, -1. And in the fourth quadrant, x is positive, but y is negative. Cosine is positive, but sine is negative. Alright, how did we do with those? So, you remembered more than you thought you did, hopefully. Alright. Let's keep going with this stuff. So, the definitions. We define these things several different ways. So, let's start. The most useful definition for us would be the x, y, and r definition. Do you guys remember the definition of sine? Think back to this. Sine was the y value, right? And this circle had a radius of 1. So y over r is our sine. Cosecant is the reciprocal of sine, so it would be cosine was And secant, the reciprocal of cosine will be r over f. Tangent and cotangent is the reciprocal. I guess I did not. Sorry. Just write that down on the bottom, or on your graphing page, you can write it next to each of those graphs. So like, I think I labeled your graph, so I would just write beside the name of each one what ratio is. Alright. So we are going to sketch the graphs of each of these trig functions. Not that we will spend a lot of time in trig drawing the graphs, but a quick sketch of the graph can help you figure out where something is undefined or where it's 0, and those are things that we will need to be able to figure out as we go on. So we're just trying to review some of the bigger ideas here. So sine. Remember, the highest y value sine hits is +1, and the lowest is -1. And then these points represented the quadrants, so this would be pi over 2, pi, 3 pi over 2, and 2 pi. Okay, you can look at your unit circle to help. You can think about your hand trick. Sine of 0. What is the sine of 0? So square root of top over 2 is 0. If you're looking at your unit circle, the y value at 0 was 0. Pi over 2, sine of 90 is +1. Okay, at pi, if you look back at your circle, sine is the y value. Sine of pi was 0. 3 pi over 2. Sine of 3 pi over 2 was -1. And 2 pi, that's back to where we began, back to 0. So remember, this was a curve. It's not a zigzag. No breaks in the graph, just a nice smooth up and down. It doesn't just start at 0 and end at 2 pi. It keeps going forever, but this was one full period. All right, cosine. So set up the same. Cosine of 0 is think about that word pair. Cosine of 90. So if you did the hand trick, square root of 0 divided by 2 is 0. At pi, down to -1. Back to 0, and up to 1. So sine and cosine are very similar in their graphs. Remember, tangent and cotangent were the ones that were a little more weird when we graphed. Because their period was shorter, they repeated more often. And they also had a lot of breaks in their graph. Because remember, tangent is the same thing as y over x, or you could also say that's sine divided by cosine. So it happens that every time cosine equals 0, we get a vertical asymptote on our graph. And if you think about the graph of cosine, that happens a lot, right? Every other point, it's 0. So we had a lot of breaks in our graph. When we were trying to get one full cycle for tangent, we went from -pi over 2 all the way to +pi over 2. And these other points we used 45 degrees, so pi over 4. because if you think about 90 degrees, cosine of 90 is 0. So tangent is undefined here. And that would also be true at the negative 90. So we did this interval because then we could put the asymptotes at the end. Right. Then, so tangent of negative pi over 4. That's like a negative 45 degrees. Tangent of 45 is 1, but the negative puts it in the fourth quadrant, so it's a negative. Tangent of 0, if you think about 0, tangent sine over cosine, so 0 over 1 is 0. Pi over 4, radical 2 over radical 2, you're back to 1. So this one looks cotangent is similar, so these points are negative 1 and 1, but cotangent we went from 0 to pi. So we did pi over 4, pi over 2, 3 pi over 4, and pi. And again, we did this so we would have asymptotes at the ends. 0 in the middle. So at pi over 4 in the first quadrant, cotangent would be a positive 1. 3 pi over 4 in the second quadrant is when it's negative. So very similar to our tangent, it's just decreasing in the asymptotes or in different spots. All right. Have I thrown too much at you, or are you remembering some of this stuff? Look vaguely familiar? You at least know that you knew it once upon a time? Secant. What do we know about secant? It's the reciprocal of cosine. So, when we graph secant, we usually kind of pretend we are graphing a cosine graph to start with. Okay, so what I usually have to do is just lightly draw in cosine. So cosine started at 1, went to 0, negative 1, back to 0, and so forth. So this isn't my actual graph. So just very lightly sketch that in, or some people didn't even draw it in at all, which is fine. Or some people drew it in and then erased it later, so any of those options are fine. Because that's not my final graph, that's just secant. But when I do the reciprocal, anywhere this graph is 0, what am I going to end up with? An asymptote. Okay, and then the high and low points stayed. So my 1s and negative 1s didn't change. But then we just flipped the graph away from the axis. So you end up with these little parabolas. So the actual graph of secant is this blue line. The orange was just my lightly drawn in line to help figure out that graph. let's look at the last one. Cosecant is the reciprocal of sine. So to draw it, we start with the sine graph. So we're lightly drawing in sine. Sine of 0 is 0, sine prime of 2 is 1, 0, and 1, 0. Alright, then anywhere this hits 0, my graph will be undefined. High and low points stay, and then we just flip the graph away from the axis. So the final graph are those blue lines. So I'm not talking about the identities yet. I just want to do some basic examples. So we're just going to add these in the margin somewhere, or if you want a piece of notebook paper and work them out on those. I didn't print these slides because I already got a couple other pieces of paper and they're not much to write down. So I figured we could just copy these down somewhere. So refresher, if I ask you to convert into radians, so that's something we'll need because anything we do in calc, it has to be in radians. So if I give you any degree, the first thing we will do is convert it. And I kind of talked about this when we did our unit circle. What do we have to do? Yes. Alright, remember when we did that, we did like 210 divided by 180? If I actually do it without a calculator, just for fun, remember you could like mark off the zeros. Remember some of your elementary math tricks? 21 and 18, what are those supposed divisible by? 3. 21 divided by 3 is 7. 18 divided by 3 is 6. 7 5 or 6. I'll try to take the opportunity periodically to review little math tricks that might help you. Alright, negative 122. That one is not so nice. Okay, you have two options. So you could go ahead and multiply by negative, or by pi over 180 and give me a negative on your final answer. We also talked a lot about coterminal angles last year because we didn't really like dealing with anything negative. And to find a coterminal angle, you would add 360 first. Both answers would be correct because I didn't specify whether your answer had to be positive or negative. So let's just go ahead and we'll just go ahead and convert it as is. But if you did add 360, that's fine. So 122 over 180. And that would have a negative on it because of the negative 122. What if I asked you to go the other way in your conversion? So not going to be as common in this class, but I need to take the opportunity to review where I can. If I said, here's something in radians, change it to degrees. How do we go back to degrees? Over. Yep, we just flip this ratio. Alright, so the pi's drop. Alright, fancy math. What's 180 divided by 5?
36.
And then you have to do 36 times 11. Or you could do 11 divided by 5 times 180. Get the same thing. What do we get? And you have to make sure you put your degree symbol. Alright. 2 pi over 3, if I want to change that into degrees. So 180 divided by pi. Pi's cancel. 180 divided by 3 is 60. Times 2 is 120 degrees. So, could we convert? Okay. Let's look at some of these. This is the type of thing that will periodically pop up, just being able to evaluate those trig functions for quadrant and reference angle. So if I said cosine of 5 pi over 6. So when I gave you those last year, I said over and over and over again, what did we write down before we did anything else? Quadrant and reference angle, every time. The quadrant. If you're in radians, it's pretty simple. You look, the top is just one less than the bottom, so that happens in quadrant 2. Reference angle in radians, that's just the pi over your denominator, so pi over 6. Okay, in quadrant 2, we have to decide if cosine is positive or negative. So we can think about our unit circle. Remember the trick I gave you? All students take calculus. So, in quadrant 2, sine is positive, so that means cosine would be negative. So my answer is a negative. Okay, pi over 6 is like 30 degrees. So if you did your hand trick, fold in the 30, cosine's the square root of the bottom over 2, so it would be, look at your unit circle, at 5 pi over 6, cosine was the x. Is that what we had written down for our order 2? Cosecant of pi. Okay, pi doesn't really have a quadrant because it just lies on an axis. So think about our unit circle. If this is 0, 0, what's this point? Okay, cosecant is the reciprocal of sine. So sine is the y. So we know that the sine of pi is 0. So what's cosecant? Reciprocal of 0 is undefined. Alright, negative 7 pi over 4. You could deal with the negative. Most of the time we didn't. What did we do instead? If we're in degrees, we added 360. If we're in radians, we add 2 pi. Alright, so 2 pi, that would be like 8 over 4. So negative 7 plus 8 would just be a 1 pi over 4. Okay, that's just quadrant 1. So pi over 4 is like 45 degrees. If you do your hand trick, the sine of 45, that would be radical 2 over 2. Alright, D. Cotangent of 7 pi over 6. What quadrant is 7 pi over 6 in? Reference angle would be a pi over 6. So in quadrant 3, all students take T is for tangent, and cotangent does the same thing because they're reciprocals. So in quadrant 3, tangent is positive, so that means cotangent is positive. Okay, if you remember the hand trick, tangent was square root of the top over square root of the bottom. So cotangent flips it. So square root of the bottom would be radical 3 over square root of the top is radical 1. So we just get radical 3. Okay, here's what I want you guys to do. If you flip over that paper, I want you to take a few minutes and try questions 1, 2, and 3. So 315 degrees you would multiply by pi over 180. And what did that give you? 7 pi over 4. Alright, 2 pi over 5, you multiply by 180 over pi, so the pi's drop. And we get 72 degrees. Alright, negative pi over 3. If you add 2 pi to that, you get 5 pi over 3. So that's quadrant 4. Reference angle is pi over 3, which is like 60 degrees. Okay, in quadrant 4, we know cosine is positive, so that means secant is also positive. The other 4 would have to be negatives. Alright, so sine of 60 is radical 3 over 2. Cosine, square root of the bottom over 2, would be 1/2. Tangent, square root of the top over square root of the bottom. So radical 3 over radical 1 is radical 3. When you have these, you just do reciprocals to get the others. So cosecant's a reciprocal of sine, so you get negative 2 radical 3 over 3. Secant, reciprocal of cosine, you get 2. Cotangent, you would get 1 over radical 3 or negative radical 3 over 3. Is that okay? 7 pi over 6, what quadrant is that? Reference angle pi over 6, which is like 30 degrees. And in quadrant 3, tangent is positive, so sine and cosine and their reciprocals would be negative. Alright, so 30 degrees. Sine of 30, radical 1 over 2 is 1/2. Cosine, radical 3 over 2. Tangent, radical 1 over radical 3, which turns into radical 3 over 3. So reciprocals, cosecant would be a negative 2. Cosine, negative 2, radical 3 over 3. Cotangent, radical 3. Any questions on those? So here's what we're going to do. I'm not done with this section yet. There's still stuff I'm going to review. I will go ahead and give you the handout for this. It won't be due until Wednesday. So we have done probably 2/3 of the section, so it won't take me the whole class tomorrow. You will have some class time tomorrow. If you choose to start this handout, you could do 1 through 3 based off what we have covered. And of course, we'll have class time once we finish our notes.
Just like opening